naughty video, I'll do it after. Right guys, here we go, a bit quiet. Here's the hot cap for all you people. So if you look at this, quiet, please, we're filming, thank you. So my thing's inside the front of it. Right, if you look at this, it's really easy. Make sure you've got sketch and surface model up as usual for your surface modelling. On your tabs, up the top, make sure you're in millimetres, this is your checklist. You get into that sequence and you know what you're doing, okay? So, chat, tell me. This is on YouTube, guys, for your benefit. So, all you do, front plane, do a centre line. Do centre lines important, don't do a normal line because you're going to do a revolve. No, you don't want to stay there. And what you do is just roughly draw that shape, 15.5 by 14.5D, and then you do the little bits here, the cosmetic bits. So this one is a 2.5 by 2.5. People chatting whilst I'm videoing for you, it's getting me annoyed. Okay, so it's 2.5 by 2.5. You see the chamfer tool does it for you. This one, just do it local. So this one is 0.5D and it's 1 mil long. Okay, or 0.75 long. Okay, it's got an R on there, like an R1 on that, which is what I should do. So I'm going to draw that profile and then show you what to do. That's the easy bit, and then the rest of it's plain sailing. Okay. So let's turn on the SolidWorks and get SolidWorks up and running. Next year, by the way, I'm going to try and get the cloud-based SolidWorks up and running. I've got to speak to Solid Solutions so that you can have SolidWorks at home and in the college, and you can literally take your files from home and take them straight to college and keep working on them for projects. Sound good? I've got to do that. I've got to have a word with Solid Solutions about this so you can have it and you don't have to download it. Just log on. The only thing I'm worried about is it has special features like the CNC machining on it, multi-axis machining and turning for you, and coding. That's one of the things I want to find out if it's got, and if it's got all the other bells and whistles like surface modelling sheet metal so you can do stuff. Anyone thinking of doing any computational fluids or aerodynamics next year? For a project? I'll see if I can I'll make sure they've got the FEA on there for you. Okay? It's really good. By the way, at the end of this lesson, do you want me to show you the FEA stuff and what it does? Structural. Brilliant. 7-page report writes for you the whole lot. Superb. You can put your name on it. Right, let's have a look over the part. Let's make sure what are we drawing in? Millimeters, yeah? Anyone drawing inches and be different? Right, let's have a look. Front plane, X and Y, go up there. Chatterboxes behind me. I'm going to take the tons and post them to Siberia. Okay. Or I'm going to make him wear a sunburn. If he keeps chatting, I'll make him wear a sunburn shirt.
Oh yeah, actually, yeah.
That's a bit kinky, that is. He's a Macam. He's a Macam, that's what he is. He's a Macam. He's a closet Macam, that's what he is. Right, let's have a look. Do that rough like that. Centre line with a rough elbow like this, okay? Smart dimension it. We can smart dimension that, no problem. Hold it. Part dimension. Oh, come on. Give me a break. You have to butt on. Let's have a look. Do this. What's the size of it? 15.5? And what's this one? 14.5? Like that. Easy peasy lemon squeeze. That was nice, was it? Trim it. Do all the editorials, the cosmetics and everything you need. Any stuff. Now we know that's 2.5 for that chamfer, equity space like that. And then we've got this bit over here. Let's do a localised one. I want to do a little bit of cheating. I'm going to go here, I'm going to put the line here and just draw it down like this. I'm then going to say to it, smart dimension, I'm going to do a vertical. I'm doing a vertical dimension like that. That one is 0.5. And this one from here, I'm going to do this one horizontal. Do this so it locks in. And the reason why I'm choosing this so you actually get these defined 0.75, like that. Trim the other one out, this line. That's beautiful. What we're going to do with this, we're now going to revolve that. Surfaces, revolve. There it is. Okay. Let's do some more cosmetics. Let's go down to boots and get some eyeliner and lipstick. cosmetics here. So you've got to have sense this way, but an engineer's got sense here. Now, let's do this. Fill it on there. Fill it as R2. Do that R2 fill it on there. Do it now, because when you thicken it, translate it into the inside and get even more thickness. Okay? This is really important. You don't get frustrated. So ready? Let's do this one. Let's do full preview. And I'll do 2 mil like this, 2 millimeters. Let's clear that. Let's have a look. Clear. And ready? Yellow. Right, like that. Beautiful. Nice. Thicken it. Now I know it's 1 millimeter thick. Okay. So let's thicken this. Let's go thicken. This one. Let's make it 1 millimeter to the inside. So we get an inside wall thickness. So we do that. Oh, is that hard? That's not hard, is it? Nice and simple. Now, what do you want to do next? Do you want? Do you want to do the thread and then do the outside features? Let's do the thread and then the outside features. Usual thing. Go up to Features tab, Hole Wizard, Thread. Now, remember, the thread on the top of the bottle is an M27 times 3 mil pitch. Okay, so we're going to replicate the internal one for that, so you can screw it up. All you have to do is, if you 3D printed this bottle, is to put a neoprene seal in the top there. Now, when you look inside the bottle, it's got like a soft, squishy bit. That's so when they screw the cap down, and when they put it on, it actually screws down so the liquid can't get out, and it creates a nice tight seal on there. It's dirt cheap. That's why they do it. Have a look inside the bottle when you lift it up next time. You unscrew it. You look at it, even on some of your household domestic products, they have like a little seal on it so it doesn't leak, especially on bleach and stuff like that. We've got a tank-proof cap as well. Same on, medicines, got antibiotics, tank-proof cap, looking inside, sort of like thing on the inside, so that it keeps it airtight, so the actual medicine doesn't go off. So let's have a look at this. So that's good, I love that. So what I want to do is I'm going to go OK. Let's put a thread on the inside here. Now, line, I want to do it 10 mil. So 10 mil, that's a bit much. Let's take that down to about 8 mil or so, 8 millimeters, like that. What we want to do is, we're going to do an offset. We're going to offset this. So I'm going to offset it, reverse it, and I'll offset that about, make sure it's about 3 mil offset. Maintain the thread length of 8 mil underneath, that's very important. So that when you've got it on here, let me zoom in into this so you can see this. I offset the thread here so that it starts to come and actually reduce it. So you introduce it to the job, but you also click the button, maintain thread length, where is it? Up here, maintain thread length. So in other words, from the base here, inwards, it maintains that length of thread manufactured, okay? So you know that it's going to be spot on every time it's screwed up tight. The other thing is, usual stuff, trim it start and finish, so it gives a nice finish, okay? And then we go okay, beautiful like me. So look, oh, it's got an why is it doing that? We need to extrude thread, not cut it. Okay, make sure it goes green. Let's have a look. Is that what we want? Look at that, beautiful. Now, a little bit of kiss and tell. What we're going to do is go onto here and we're going to actually trim this and make a little chamfer on there. Chamfer, 1 millimeter. Just go down onto here. So you can do this. I'm going to do it 1 millimeter. That's going to cause problems. Look, that's caused a problem. It's done conical on there, so we don't have to do that. I'm just going to undo that for a second, so it doesn't have to really worry on there. We can actually do this. We can actually go into here, and I can go see-through. What I'm going to do is I'm going to go front plane, and I'm going to put a sketch. Front plane, let's have a look, front plane, sketch a little bit like that. We'll go down here to the middle, and what I'm going to do is I'm going to chamfer off inside there. So what I'm going to do is put a little triangle in there, and I'm going to go into this chamfer. I can do it on the outside if I want. No, I'll do it on the outside like 3D. Stuff it. Ready? Let's have a look. I'm going to do it. I'll use it to the inside. Let's have a look at the drawing. Check the drawings. Let's have a look at the drawings. Yeah, he's got a chamfer at 145 on the outside. So you don't have to do that revolve. Let's do this. Features. Walk here. Let's have a look. Let's do this. Chamfer. 1 millimetre. Outside like that. Beautiful. Just like me. How's that? Good. Let's do that top bit. Now, this top bit, go looking down from the top plane, and where the outside major diameter is, you actually do a 1 millimetre diameter circle on the actual outside radial, outside lens line. Do you want me to fill it up for you?
Right, that's right.
You sure? I've got liquid. Bye everybody. Bye. Got to hold hands, don't worry. So what I want to do is look at the top and draw those circles. So let's use this and use the old geometry as like a reference, a quadrant point. Do the quadrant point at the top or wherever you want, and then just do a circular ray cut. So we cut one and then we pat it. So this is efficiency. Look on the surface, normal two.
I've got a video as well.
What I'm going to do is look at the plane that goes on there, which is like that, top plane, and sketch a circle there. Now what I'm going to do is go up to here, there's a quadrant point, I'll put out a circle, so the radius has got to be 0.5 mil radius, okay, 0.5. Why is it 0.5 mil? So that when you cut it down, it doesn't reach the wall thickness, because you've got 1 millimetre wall thickness, don't you? So you're just cutting through a little 0.5 mil radius into it, and then you're going to fill that over, and you're going to finish it and pack it. So watch, ready? Features, extrude cut, reverse it, and I want it to go through all, so it goes through the whole body. Okay, this, that's not gone through there, has it? So what we're going to do is direction, both directions. So the second direction, up to next, so that's how's that? Now see this, if you do that and you try and do in the bottom cap, yeah, get grip, but you could also, it's because it's sharp, it's a sharp edge on the plastic, you could actually cut a person's finger open. It gets to the child's fingers, like, you know, who's sort of 5-year-old gets all that, it could easily breach their skin, cut it open, and blood everywhere, you don't want that. So what you've got to do is you've got to take off any sharp edges. So in this case, I'm going to do a fillet of about 0.2. I'll just go onto there like that, 0.2 fillet, okay it, and now what we're going to do is shift, control key, get that and then fillet, and then we're going to circle pattern, circle pattern. Doesn't matter what edge, I'll use that edge around there, and do about 30, 38 I think it is the number. Like that, 38, and go okay. And there it is. How's that? Does that look good? And now what you can do is you can do this. And you can do this. Do materials and appearance. Okay, and you can do plastic. Do a medium gloss. I can actually make it so it's in like green or whatever, or red. Let's do it red for like a Coca-Cola bottle thing. Same with that whole pattern. You do the whole job. So let's have a look. Like this. How's that? Nice.
So when you do this, you get it to actually like physically show threading onto the bottom.
Now, this is a good question. James brought up a good question. At level 3, you don't have to do this, but in SolidWorks, when you do an assembly and you do all the threads, you can actually do kinematics, as they call it, advanced threading, advanced mates, and actually have it so it screws on and stops when it gets to the end of the thread. That's how they do stuff on animation, professional animation in CAD, for advertising, anything, to show assembly and that, how it goes together in the right sequence. This is really important, how to assemble things in the right sequence to get a job correct is vitally important, especially if you're doing something like aeronautical, aerospace. That's critical. Doing it on high-speed trains, same thing. It might be chunkier engineering, the principles are the same also.